Okay, after doing slice timing, the next pre-processing that we usually do in our lab then is to co-register, to do some co-registering. Remember, co-registration, as we talked about in class, is about registering two images in a rigid body application, in a rigid body algorithm, where the two images might be of different modalities. So for motion correction, it's rigid body, but all the images are in the same modality. So you got your EPI registering to the other EPI that in a rigid body way because it's from the same subject. In this case, it's also from the same subject, but one image might be an EPI, but another image might be a T2. And because the contrasts are different, you can't really use the same motion correction kinds of algorithms. You're going to have to use something more generalized. And that's what co-registration does. Okay. And to do that, it's pretty easy. And we will talk about it in class about the principles of why we do co-registration, how we do it, in what order and all that. All right. So I'm not gonna go through the details here, but I'm gonna show you how to do it in SPM 12. So to co-register, the first thing we want to do is to co-register the T2 to the EPI. We want to move the T2 image. I'm just gonna highlight it here. We want to move the T2 image, which is this one, this file here, into the same location as the first volume of the first EPI run, right? So we want to move this T2 to the same space as this this first volume of this guy here. So to do that, I'm going to click the co-registration button. And in this case, we don't really need to reslice or estimate and reslice. We just need to estimate, because the important thing here is that it's not really, we don't really need a new image. What we just need is that the header, which tells us how to read the image, will already instruct any nifty file reader. Like when you open the file, you're gonna have to apply the geometry in the header that's in the header, so that you can read the data correctly in the right orientation. All right. Technically speaking, you can do that in the realign step as well. You don't really need to reslice, but I found that to reslice things makes things easier to visualize and to see the real outcomes. All right. So you can also reslice a co-register image if you wish, but it's not really necessary. But do note that this is the same issue when we only work with estimate, that the file name won't change, but the header will be rewritten. Okay, so that means that will be a modification date. The date that the file has been modified and time will have changed, but the file name won't change. So this goes back to you being very aware of what's been done on which file, because it may not be obvious just by looking at the file names, especially in the cases of when you just do estimate. All right, so let's co-register the T2 to the first volume of the first run EPI. This is very easy. I'm just gonna click, and I always get lost with this, but you can always look at the help. All right, the reference image. Which is the reference image? This is the image. If you look at the bottom, this is the image that is assumed to remain stationary. So as I said, we want to move the T2 to the EPI. So the EPI doesn't move, so it's stationary. So let's go ahead and specify that this reference image is going to be the EPI image. And in this case, you can always select the any one of the EPIs, the original EPIs, since the first volume up to this point, the way we've done things, stays still, hasn't moved. All right, it's all the other images that have moved. But just to avoid confusion, we're just going to carry on from our previous slice timing step. So we're going to use the ARY01 rep1 blah 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 series 23, and we're going to use volume 1. All right, so we're just going to go ahead and select this image and click done. That's the reference image to which all the motion and co-registration is going to it's going to stay still, and everything else is just going to move towards this image here. All right. The source image is the image that is jiggled about. So that's the one that's moved, And so as we said before, that's going to be our T2 image. Remember why we're doing this, okay? We're wanting, because our EPI image is really good for temporal resolution, right? But you can see it's not as good in terms of the spatial resolution. So we use the T2, which has a good spatial resolution, and we register that so we can leverage the two, and we will have an image that has good spatial resolution and also better temporal resolution than in this case to get the both signal changes. So I'm going to select the T2 and click done. It's very easy. And that's it. All the other parameters we don't need to change at this point, all right? And we don't need to specify other images, although in your spare time, do go ahead and take a look. At some point, you're going to need it, I'm sure. And also, you should be aware that it's not always the case that the EPI remains stationary. Sometimes we make the EPIs move as well, and that's when you might want to use the other images, because you want to move not just one EPI image, one volume of the EPI image, but all the other volumes of the EPI images together as well. That's when this becomes important, right? But yeah, so in those cases, we might switch the positions, what's reference, what's source around, right? You really need to understand what you're doing here so that you don't get messed up or confused. In the case of our tutorial in this course, we want to minimize having to move around too many things. So we keep the EPI images stationary, and we move just that one volume of the T2 to match the EPI, right? Alternatively, you would have to move all 150 volumes of the EPI to match one T2. That seems really inefficient. So that's why we're doing it this way. In this case, that's all the settings we need to do. So just like before, I'm going to save this batch so we can have a log of what we did. And I'm going to, oops, I think I saved it in the wrong place. I'm going to move this later, but I'm just going to go ahead and do coreg. And I'm going to need to specify that this is coreg T2 to the EPI. All right, find it helpful to label this detail. So just let me, because I don't want to get confused. So let me just move my batch files to the correct place, so I don't get confused here. Right? Here we go. Right. So I moved the pre-processing batch here where it wasn't. Sorry about that. Okay. So it's been saved, and here the play button is green. You can go ahead and play it. It's really simple. And the key result you'll see is watch out in this graphics window. Remember, you don't want to close this. Once you close this, it's really hard to get it back. But you're going to need it, so leave it open. I'm going to let it run. Once it's done, you will see this display. And this is really important because here is where you need to use your eyes, and I do really recommend that you do it. The top part is not really important for most people, okay? But what it is the joint histogram of the intensities. And that's really what SPM uses to do the co-registration algorithm, all right? So you can see that it sort of tries to kind of like maximize the overlap, basically, between the two images in terms of the intensities of the voxels. And what that translates to is the set of parameters in the XYZ direction by which you have to move the T2 image to match the EPI image. And it's a rigid body, so it's the same 6 parameters: XYZ translation, XYZ rotation. All right. So yeah, this is all the technical part, and that's really not the key point of this screen. The key thing is here at the bottom. You'll see that on the left is the EPI, and on the right is the T2. Now it's important to check that the co-registration went well, and that your imaging data are well behaved. So we've checked the motion before, and now we want to check whether the T2 having been co-registered is really co-registered, because sometimes things might go wrong, you never know. So it's good to check. And how you check is by using the blue crosshair here. It's really easy. Just click I like to do, clicking the front here first. And here, it's usually the case that in your EPI, you're going to get dropout in the front. So this is okay. You see that there's the border of the brain anatomically is here, but you don't see that in the EPI, all right? But you just want to check that it's not kind of like very, very badly behaved, all right? This is reasonable. The key, more informative parts will be at the back. So there's minimal distortion at the back. You see that they line up. So this blue line here is cutting the brain at the back of the occipital lobe, and that's what's happening here. Okay, you can see it in all views. Then you can go ahead and check the left, the right, and then the top, and then the bottom. And for the bottom, kind of like have to surf around to find the lowest part of the temporal lobe. Okay, that's the lowest part of the brain. And again, you can see sometimes there's this cutoff, and that's okay. It's you visually you can inspect, you can see that things are matching up pretty well in the rigid body sense. There might be some local distortions because of the EPI, so that's expected, right? And then I find it also helpful to check like the ventricles, because that's not just the boundaries, but also the internal structure to make sure that things are well behaved. So you can see that this is the ventricles, the edge of them, the horns. Okay, then you can check that they're all doing it well, they're being matched well. The other structure, again, that would be very useful are things like the Corpus Callosum. All right, so if you can find it, so remember white is dark here, and you can see that sort of capturing it pretty well. All right, so I like to cycle through this step just to make sure that the co-registration behaved well. In this case, it looks like it did. So we're done for co-registering T2 to the EPI.